All right, guys. There we go. So I think I've got our echo fixed. Saida, thank you so much. Yeah, it has been a really long weekend. Today is probably going to be a fairly short class. I'm still at my parents' house. We're up in the panhandle of Texas, and their internet is not always super secure. We're kind of out in the country, so if I get kicked out, just be patient with me. It's been letting me back in. Thank you. I'm tired and I'm pretty fuzzy headed, so I don't know. It may be a may not be very good at answering your questions today because we haven't had a lot of sleep. And of course, our mind has been elsewhere. But I did not set up to use my document camera. So today we are going to focus on the parts out of 12.4 and 12.5 that we can do using with me interacting with the screen. So we're going to focus on our special angles. We're going to do simple proofs. If we're not having too many internet issues, I will try to answer some homework questions if you have them, except, you know what, I don't have the book, so I can't look those up. We'll do what we can get through today, and then what we don't cover, go ahead and send me emails. I've been checking emails. And then we will wrap up covering chapter 12 on Thursday. I think that we can balance out and get enough done today that Thursday will be okay. All right, can everyone hear me okay? Okay, I went ahead and turned off my video because I think that will help with the internet. And I've got an attendance form, so don't let me forget to post that link. In fact, I'll go ahead and post the link, but somebody remind me later on in the class that I need to tell you what to respond with on the attendance form. Okay, does anyone have any questions to ask me about anything before we jump into our special angles? Okay, now we're going to, Saida, yes.
Sorry, I'm the one who always have questions. My question regarding the mathematician that's due in tomorrow.
Okay.
I'm a little bit confused. I know it's not the full assignment that's due tomorrow, so for that we just need to send in written that the name of the mathematician and what we want to do and which NCTM we're gonna incorporate in our lesson.
Yes, so it doesn't even have to be a paragraph. It can be 3 sentences. You need to give me the name of the mathematician you plan to focus on, the concept that you plan to focus on, and the standards that you plan to focus on. And if it ends up that you need to make a change later on, that's fine. If it's a major change, then you'll need to notify me so I can double check and make sure that it's still a mathematician and a concept that is allowed. But otherwise, it will be fine if you need to switch later. Shanique?
So for when you say the standards and the process, the process standards and the
content standards.
Content standards. Okay, so the process standards, you mean like problem solving or reasoning or communication? Okay.
Yeah, they're all on that one page together.
Okay, got it. Thank you.
No problem. And if you are not aware, I did just a short, I think it was a 5 or 6 minute video about how to find standards in that PDF file. So if you haven't watched that, watch that, and it should help you make sure you know how to go through there and find what you're looking for. Anything else? These are easy ones. I can answer these today. Okay, so we are going to work on these special angles. The first one I was trying to find the second one online because I didn't have it. I don't have a copy of it, and I don't have anyway, I was trying to find it online and I picked out the wrong one, but I decided, you know what, that first one looks good. It will be a good one to practice. So I'm going to switch to my where I can write on my PDFs because it's a little easier to see on when I do it this way. Okay, remember you can zoom in your screen if you need to. It gives you the location. I found it on the online book. If you want to just do a quick sketch, we have 2 parallel lines and then 2 intersecting lines that cross those parallel lines so that we have a bunch of special angle pairs. And then we're given the information about 2 angles. We're given measures for angle 1 and angle 4, and we're told that L and M are parallel to each other. So angle 1 is 80 degrees and angle 4 is 125 degrees. Let's start here. Let's start by saying the measure of angle 1 is 80 degrees. What angles are congruent to angle 1? Angle 1 is congruent to what other angles are going to have the same measure as angle 1? 11, yeah, we know that 11 will have the same measure. So let's go ahead. I'm going to mark 1 and 11. Megan says 16. I haven't solved this yet, so I've got to look through too. Yes, 16 will have the same measure as angle 1, and I'm not going to do this in very good mathematic notation. I'm just going to list them all out there. Angle 1 is congruent to angle 11 and 16, and because of 16, we've got 18. So all of those have 80-degree measures. Let's go ahead and move to angle 12. What would be the measure of angle 12 here? And I'm going to change color. What's the measure of angle 12? If angle 1 is 80 degrees, what's angle 12 going to be? And think about what you've read or what you know from previous math classes about special angle pairs. And so are we stumped on angle 12? Angle 1, go ahead.
I'm not seeing angle 12. Oh wait, never mind. I see it now.
Okay. All right, there we go. So Saida, yes, angle 12 is 100 degrees. And we know this because angle 1 and angle 12 are supplementary. They form a straight angle. So let's go over here and that we're going to say the measure of angle 12 is 100 degrees. So what's going to be congruent to angle 12? Angle 12 is going to be congruent to what other angles? Angle 2. What else? We have some other 80-degree angles, remember. So there you go. So we've got 2, we've got 15, and we've got not 6, but we have 17. 2, 15, and 17 are going to be 100 degrees because we've got 80 and 100 add up to be that straight angle, that straight line, that 180. Let me change colors here for angle 4 so that we have everything in its own color. I think that's going to help us figure things out. Okay, so we got those conjunctions of angles. Let's move over and look at angle 4. Angle 4 is 125 degrees. The measure of angle 4 is 125. We were given that. That was one of our givens. So angle 4 is going to be congruent to what angles? Angle 4 is going to have the same measure as 13, yes, because that is a parallel line cut by transversals, and those are positionally in the same position. So 13 is going to be congruent to angle 4. What else? 19 and 6. There we go. So 19 and 6. 6 is vertical angle. It's across from angle 4. And 19 is a vertical angle to my 13 degrees. So we've got 19 and 6. So those 4 angles are all going to be 125 degrees. Megan, so you're looking at angle 3. Angle 3 is different positionally from, so what we're interested in. Let me see if I can find a unique color. So we've got these 2 parallel lines, and they are cut by a transversal. I know these two lines are parallel because it is given to us that L is parallel to M. And when I have two parallel lines cut by a transversal, then I have special angle pairs formed. So angles that are in the same position in relation to the parallel and the transversal. So angle 13 is on the top of the transversal to the left of the parallel line. Angle 4 is in that same position, above the transversal and to the left of the parallel line. And then angle 6 is the vertical angle. So we know that vertical angles have the same measure. So any angle that is directly across from an angle is going to have the same measure. Okay, so let's look at, let's look at, did that help a little bit, Megan? Sorry, that's my parents' dog. That's Buddy. He's a happy dog, but he gets excited. Okay, so if angle 4 is 125 degrees, what is angle 5 going to have as a measure? What's the measure of angle 5? Saida, that's right. 5 is going to be 55 degrees. The measure of angle 5 is going to be 55 degrees because 5 and 4 are supplementary. They form a straight line, and Megan, yes, they have to total 180. So if angle 5 is 55 degrees, what other angles are congruent to angle 5? 7 is the vertical angle to angle 5, and then we've got these angles over here that are positionally in the same position, 14 and 20. You guys are getting this. Excellent, excellent. Good job. Okay, so now we have these 4 angles in the middle. That's what we're down to, are these 4 angles in the middle. And we have a couple of different ways that we can get the measures of the angles in the middle. Does anyone have a starting place that they see, something that they want to look at first? Angle 3. So Megan, how do you think we can come up with a measure for angle 3? Three looks like 13. Okay, so it does visually look like 13, but we don't have a good way to check that. There's no relationship that I can form that can help me figure out 3 that I can think of right now. I know that 3 and 9 are going to be congruent, but I can't guarantee that 3 and 13 would have the same measure because they're not on parallels. 3 plus 10 is 180. 3 plus 10 is 180. Okay, that's true. That's a good place to focus. So I know that 3 plus 10, 3 and 10 are supplementary, and I know that 10 and 8 will have the same measure. I can't figure out the measure of 3, but could I figure out the measure of angle 10? Saida, how can I figure out the measure of angle 10?
Because
With the
exactly,
Go ahead, Saida.
triangle, so we know the 14 and 11. So we should be able to, 60, 60, 60.
Absolutely. As not 60, 60, 60, but they're going to add to 180. The
Yeah,
angles
exactly.
in the triangle add to 180. And we know that angle 14 is, let me find angle 14 on my list. Where's angle 14 on my list? Oh, right here. Here's angle 14. So we know angle 14 is 55 degrees. And we know that angle 11 is 80 degrees. And then we have yes, Megan, all the angles in any triangle are those 3 angles in any triangle will always add up to 180 degrees. And we're going to prove that on Thursday with our activity manual. But I don't have my document camera, so we're not going to do that today. So if these 2 angles are the 2 angles in the triangle, what's the measure of the third one going to be? 45. Okay, so my angle 10 is going to be 45 degrees because it's that third angle in that triangle. So the measure of angle 10 is 45 degrees. And what angle is congruent to angle 10? We said 8, right? 10 and 8 are both going to be 45. Okay, so yeah, 10 and 8. We're left with 3 and 9. If 10 and 8 are 45, and we know that we've got that supplement there, what will be the measure of angle 9? It's going to have to be 135. There we go. So 135, and angle 9 is congruent to angle 3 because they're vertical angles. So we're focusing on angles that have the same position, so they're congruent, and then angles that have special angle pairs, like our vertical angles. Hold on just a second, guys. I've got a dog visitor, and I'm going to let him out. Hey, go down. Okay. All right. Got it. All right. Let's move down. Let's go ahead and move down to the next one. And this is the one that I had posted for us to go over. It's kind of hard to read it over here in the upper right, but that says L, M, and N are all parallel lines. So these three lines are parallel to each other, which means we have positionally some special angles situations going on. And we're not asked to name all of them, to find the measures of all of them, just these four, 1, 2, 3, and 4. So we're given some information, and we're asked to find the measures of those other angles. So let's figure out where we can find a starting place here. Does anyone see where we could find a starting place? We're going to need to solve. We can. Oh, let's see. So can we start with angle 1? Well, angle 1 is going to be congruent with x minus 15 degrees because they are positionally in the same position. They're on the top of the transversal. They're on the upper side of the transversal. And to the left, or excuse me, they're on the upper side of the parallel lines and on the left side of the transversal. So they're in the same position. So they will have the same measure. So once we know what x is, we can figure out 1. What other angle is going to have the same measure as angle 1? Angle 2. Angle 2 will have the same measure as angle 1, not 3. 3 won't be the same measure, but angle 2. So angle 1 is going to have the same measure as angle 2, and they are both going to be equal to x minus 15 degrees. So once we figure out what x is, we can find the measure of angle 1 and 2. 3 is not going to be the same measure. I could relate 3, though, to this angle because these two are going to be supplementary. They're going to add to 180, right? So angle 3 plus that x plus 12 degrees is going to have a sum of 180. They're going to be supplementary. So we're starting to connect some things, but we've got to figure out a starting place. How about this? This x plus 12 degrees down here is, no, actually it's not the same as 4 because they're not related. Yeah, you just figured out they're on different transversals. But this x plus 12 would have the same measure as this right here. Do you agree with me, guys? This angle doesn't have a number, but do you see that positionally these two angles that I just marked in dark green are on the top of the parallel and on the right side of the transversals? Okay, so Shanique sees that those two are going to be congruent. Everybody else okay with that? Okay. If those two are congruent, then our next step that we can show is that these two are supplementary. They form a straight angle. So if x plus 12 degrees is going to be the same thing as this upper angle right here, this is also x plus 12 degrees, then I can say that x plus 12 added to that other angle, 2x minus 18, is going to be equal to 180 degrees. Those two angles measures are supplementary. Everybody okay with that? Okay, so let's solve for x. Thank you, Shanique. Yes, yes, excellent. Let's solve for x. So we're going to add like terms. We've got 3x, and then we've got 12 minus 18 is negative 6 degrees. So I'm going to add that 6 degrees to both sides, and I get that 3x is equal to 186 degrees. Anything over itself is 1, so x is equal to 62 degrees. Okay, so now we've got some progress. If x is 62 degrees, then we know, for example, that this angle is 74 degrees. And if this angle is 74 degrees, what's the measure of angle 3? Yes, Mary, because this is one set of lines, x is going to be the same for everything through here. Shanique, there you go. So if x is 74 degrees, then because these are supplementary, we know that angle 3 is 106 degrees. And if angle, well, I don't think that helps me with anything else yet. Angle 3 is 106 degrees. Where else can we go with this? We can figure out x minus 15. What will x minus 15 be? Remember, x is 62. X minus 15 is 47. So this is 47 degrees right there. And if x minus 15 is 47, what else is 47? There we go, angle 1 and angle 2. So angle 1 is 47 degrees and angle 2 is 47 degrees. So we found 1, 2, and 3. We haven't done 4 yet. Ben, thank you for letting me know that you're here and active. Excellent. Yeah, angle 1 and 2 are both 47 degrees. So we found angle 1, 2, and 3. We need to figure out angle 4. Anyone have a suggestion of how we can figure out angle 4? I can't see who has their hand raised. Just holler out for me.
It's me, Saida.
Perfect.
Okay, so I'm just saying it, maybe I'm wrong. So we know the inside angle for it's 74, opposite to 3, that's x plus 12.
Yep.
We know the, okay, we know the number 2 is 47. So,
yes.
It was adding up in my head, it's not working anymore. I was going for like a triangle so we can figure it out, the inside angle opposite to 74.
So we could get to the triangle, but that would be harder. Shanique, what have you got for us?
So the angle next to angle 4 on the other side is corresponding to the other angles that are 47 degrees. So wouldn't you subtract 180 minus 47?
Yes, that's good. That works. This angle right here is in a corresponding relationship. We got alternate interior angle. We've got the same position between the parallels. So this angle is definitely 47 degrees. What does that make angle 4? $133. Absolutely. So this one is 133. I want to also point out you've got another angle relationship there. If I have angles inside the parallel on the same side of the transversal, those two angles are always going to be supplementary. Those are going to add to 180. So angles between the parallel lines on the same side of the transversal will be supplementary. Now, So some students, these special angle relationships really click with. Sometimes it's a struggle and you've got to practice with them. If you are one that needs a little more practice, you'll notice that in the lesson folder, I posted a couple of links where you can go get more practice with your special angle relationships. Does anyone want us to explain something else on this this problem before we move on? Okay. The next thing that I want us to look at is the simple proofs page. You are asked to have printed off the simple proofs involving angles page. I'm going to give you just a second and let you read that first paragraph. All right. So let's work through this. Now, does anyone remember doing proofs in a math class before? Maybe formal proofs in geometry along the way? No, nobody's done any proofs? Yes? Okay. This is not a formal proof with multiple steps. We're going to do as kind of a simple, straightforward proof. The key to proofs, however, is that you need to make sure that you only use what you're given. So you know a lot of special angle relationships already. That's a long time ago, yeah, but you remember doing that step-by-step process where you have to show that one link is true, and then you show the next link is true, and then you show the next link is true until you've got from start to finish. Well, we're going to do that, but we're going to do a simplified version. The key to doing these proofs is that you don't say, oh, I know this because these are vertical angles, or these are alternate interior angles, or what you're going to do is you're going to use only what you're given to start to prove what we're being asked. Now, using what you're given, that changes for each problem. For this first problem, we are going to be given that vertical angles are congruent and that corresponding angles are congruent. So that is problem number 1. We're given those two things, and we are asked to prove that angle 4 is congruent to angle 6. So this is what we're trying to prove, and then I know those two things, and so I can use that to help me while I try to prove. So we're going to prove that angle 4 is congruent to angle 6. Now we know that that is a special angle pair, but we're not going to name that. We're going to use these two bits of information right here, vertical angles and corresponding angles, in order to work through our proof. I'm interested in angle 4 and angle 6. Well, vertical angles. I can say, you know what? I know that angle 2 and angle 4 are vertical angles, right? So I can write down and I can say angle 2 is congruent to angle 4, and then my reason is that they are vertical angles. Can I also relate angle 2 to angle 6? How could I relate angle 2 to angle 6? Saida, how do they relate to each other?
Because if angle 4 is equal to angle 6 and angle 2 is equal to angle 4.
Oh, no, we don't know 4 is equal to 6. We can't make that step yet. We've shown that angle 2 is congruent to 4 because they're vertical. Can we show that 2 is congruent to 6?
Because it's the parallel lines and the line is crossing at the same angle.
Catherine, you got the word I was looking for. 2 and 6 are corresponding angles, and that's one of my givens, so I can use that. So my next step can be to say that angle 2 is congruent to angle 6, and my reason is that they are corresponding angles. So now, Saida, everything you were saying was right, but you were trying to use information that you knew that wasn't given to you in the problem. And with a proof, you can only use your givens. I was given vertical angles, So I can show that 2 is congruent to 4 because they're vertical angles. I was given corresponding angles. 2 is congruent to 6 because they're in corresponding positions. Now my third step, I can go ahead and I can wrap it all up together. I can say, because angle 2 is congruent to both angle 4 and angle 6, I know that angle 4 has to be congruent to angle 6. So I got to what I was asked to prove just by using givens. Because angle 2 is congruent to each of those angles, they have to be congruent to each other. Okay, so very simple, not the long drawn out formal proofs that you did in geometry. Very simple proof. My rule, though, is that you can only use your givens. Now, what type of angle relationship do 4 and 6 have? What special angle pair would I call them? Four and 6 are what? 4 and 6 are alternate interior angles. Yes, alternate interior angles. Alternate interior. They are interior between the parallel lines. They are on alternate sides of the transversal. So interior means between the parallel lines. Here's a parallel line, here's a parallel line. They're both between the parallel lines, interior. And they are on alternate or opposite sides of that transversal, the line that cuts the parallel lines. What is another pair of alternate interior angles? We've got one more pair of alternate interior angles here. There you go, 3 and 5. Angle 3 and angle 5 are also alternate interior angles. So they are also going to be congruent to each other. Okay, now I need to see, we're going to move to the next page. Let me erase this and make it pretty again. And then I'm going to try to take a snip and see if I can bring it with us to the next page. Give me just a second. I didn't think this all the way through when I started working it out like this, but I think that we can absolutely make it work. So let me scroll to number 2. And I think maybe, oh, it's not going to let me paste because I'm in a PDF. Oh, goodness, guys. Okay, so that didn't work. Let me reassess. We can fix it. Okay, so we have parallel lines cut by a transversal, and our numbers are 1, 2, 3, 4, 5, 6, 7, 8 in that order. Okay, that'll work. All right. How could I prove that 1 is congruent to 5 if I know that vertical angles and alternate interior angles are congruent? So I'm proving that angle 1 is congruent to angle 5. That's what I'm trying to prove. I have 2 givens. My givens are vertical angles and alternate interior angles. Those are the only reasons I can use in my proof. What could I start with? What could my first step be? My first step could be vertical angles. Mary, which 2 angles do I want to use as my vertical angles? Because I have options.
Okay, for those ones, would we say the vertical ones that we have is going to be 1 and 4?
No, 1 and 4 are not vertical.
They're not, oh, I'm
1
sorry.
and
1 and 2. Is it 1 and 2?
no, actually 1 and 2 are they form a straight line. Vertical are opposite each other. Which angle is opposite angle 1?
That's going to be opposite. No, I'm sorry.
Angle 1. That's okay. Angle 1 is actually vertical to angle 3. Do you see how they are directly opposed to each other?
Oh, I see it now.
Okay, so vertical means, when you're talking about special angle pairs, vertical means a little bit different than what we think of positionally just in life. Vertical means it's going to be directly opposite it. So it's not side by side, it's directly opposite. But that's a good place to start. We can say that angle 1 is congruent to angle 3 because they are vertical angles, and vertical angles are given to us. So we can use that as a reason. Now we've shown that 1 and 3 are congruent to each other. How can I use the second given for my second step?
I have a question. Why
Okay.
didn't we say that 1 and 7 are congruent?
1 and 7 are, we only have two givens. We have vertical angles and we have alternate interior angles, and that is not one of our givens. 1 and 7 are not either vertical or alternate interior.
Okay, all right, thank you.
No problem. I used vertical angles. Let's make our next step use alternate interior angles.
So would it be angle 3 and angle 5 are alternate interior?
Absolutely. Angle 3 and angle 5 are congruent because we're told that alternate interior angles are congruent. And those two angles are interior to the parallel lines on alternate sides of the transversal. So we know that 1 is congruent to 3 because they're vertical. 3 is congruent to 5 because they're alternate interior. Our third and final step, we can say therefore, and I make a little triangle out of dots. That just means therefore, and I can make my leap to my final statement that I was proving. I can say angle 1 is congruent to angle 5 because they're both congruent to angle 3. Since they're both congruent to angle 3, they have to be congruent to each other. So we used only our givens to prove that angle 1 and angle 5 are congruent to each other. Now, what would I name angle 1 and angle 5? How are they a special angle pair? What would I call them positionally? Corresponding. Shanique, yes, they are corresponding angles. They are in corresponding positions because they are both on the upper side of the parallel and on the left side of the transversal. Angle 1 and angle 5 are above their parallel and to the left of the transversal. There are 3 other corresponding angle pairs. Can you guys name me some corresponding angle pairs? 4 and 8. Angle 4 and angle 8 are in corresponding positions. Therefore, they will be congruent. What angle is in the corresponding position to angle 2? 2 and 6. So we've done 1 and 5, 4 and 8, 2 and 6. What about angle 3? What does angle 3 correspond to? Angle 7. So those pairs of angles are in corresponding positions. Any questions about that one before we move on to number 3? All right, let me scroll down and I'm going to sketch our angles again real quickly. We have parallel lines, we have a transversal, we have 1, 2, 3, 4, 5, 6, 7, 8, so that we have everything in the same place. All right, suppose that K and I are parallel to each other, so we've still got the same setup. We've got parallel lines cut by a transversal. What type of angles are angles 3 and 6 in relation to the lines? Angles 3 and angle 6. Did I number them wrong? I did. I numbered them wrong, guys. Let me erase and fix my problem. You guys let me get away with that. You got to watch me today. This should be angle 6, and that should be angle 5. I did my sketch wrong. So we're asking about 3 and 6. What would I call angle 3 and angle 6? In relation to the parallel lines, are they exterior or interior? Interior. In relation to the transversal, are they on alternate sides or the same side? Same side. They are on the same side, interior to the transversal. Now, our book does not give those a name other than saying they're interior angles on the same side of the transversal, but I looked it up, and I discovered that we can call those consecutive interior angles. Consecutive interior angles. But if you want to write down that they are interior angles on the same side of the transversal, that is great. Now, we've already shown previously, we were talking about it, that those two angles are going to add to 180. How could I prove that? What is something you know that could help you get to a proof that those are going to add to 180? And there are a lot of different ways to do this. So you can try to plot a plan, and we'll see what we can do with it. Somebody raised their hand. Help me out. I'm not sure who raised your hand, but tell me what you think.
I was thinking about that 2 and 3 together should be 180. No, I'm sorry.
That's right. That is absolutely right. You're good. Angle 2 plus angle 3 equal 180 degrees because they form a straight line.
The same thing with 6 and 7.
Okay, so you can do this without pulling in 7.
Okay.
So somebody else help us get to that, or Mary, go ahead to the next stop. If I know that angle 2 plus 3 is 180.
So since they are interior and they are opposite angles, they should form 180. They should have 180 degree. Because I'm sorry, I imagined it as a parallelogram, and all the sides, all the angles should be 360. So each.
Well, we can't make that leap. Okay, so we can't make that leap. I think that we might, if we spent some time working around to that, we could. But I want us to go even more directly to that next step. Now, my goal is to say that angle 3 plus angle 6. Excuse me, angle 6 is 180. Right now, I've got angle 3 plus angle 2. Can I relate angle 2 to angle 6? Can I relate angle 2 to angle 6?
Yes, angle 2 is, they are the corresponding angles.
Okay, so angle 2 is congruent to angle 6 because they are corresponding angles. That works. So if I know that 2 plus 3 is 180 and angle 2 is congruent to angle 6, I can say, therefore, angle 3 plus angle 6 is 180. Because 2 and 6 have the same measure, I can just replace one angle with the other, and my statement is proven. So see, that was not as hard as you thought it was going to be. We get there because we showed, okay, this is true because those are straight angles. 2 and 6 have the same measure, so it doesn't matter which number I put there. Angle 3 plus 2 is 180. That means angle 3 plus 6 is also 180. Any questions about that one? Now, once again, you're going to be asked to do some simple proofs on your own. Just remember to use only the givens. Remember to use only the givens when you're doing the simple proofs. Now we are going to skip the activity manual page because, like I said, I don't have access to my document camera today. We're going to do one more thing together. We're going to talk some more about angles, but we're going to focus on the sum. Mary, in this fact, what you were saying leads us right into these two homework problems. Hopefully you already printed these. These were from these are out of the 12.5 folder. We're covering 12.4 and 12.5 this today, and then 12.5 and 12.6 on Thursday. So this is out of the 12.5 folder. Mary, you were talking about a parallelogram. A parallelogram is a quadrilateral. Did you tell me what is the sum of the angles in a quadrilateral?
It should be 360.
Yes. So let's look here at the second one. B, this is a quadrilateral. It's not a parallelogram. But the sum of the four angles is going to be 360. So I have four angles here. What are the measure of these two angles each? It's going to be 90 each, Faith. That's right. You got that little box. You know that that's a right angle. So these two angles, those add up to 180 because I have two right angles, correct? And then if I add in my other two angle measures, I know that the sum is going to be 360 degrees because the four angles inside a quadrilateral will always add to 360. And that's something that we're going to prove on Thursday when we do that activity manual 12.4.1. So take it on faith from me today, and then we're going to prove it on Thursday. We're going to show why. And this is just some algebra. I'm going to solve this algebra problem. I'm going to subtract 180 from both sides because that helps me simplify. So it's going to be equal to 180 over here. And then on the left, I've got x and x is 2x. 32 minus 12 is plus 20. So I can subtract the 20 degrees. And I end up with 2x equals 160. So I know that x is 80 degrees. Now the question was to find all the challenge was to find all the angle measures. Well, I know that these are 90-degree angles. What's this first angle here? What's the measure of this angle? 112. Ah, be careful with your addition. Watch those little mistakes, right? What about the last angle? What's that remaining angle measure? It's going to be, look at it again, Saida. It's x minus 12. Saida, you did x plus 12. Faith, watch your subtraction there. What do I get when I do x minus 12 there? 68. There we go. And if you wanted to double check yourself, that's fine. We get in a hurry sometimes and we make those mistakes, and it's better to make them together instead of on your homework or on your test. so make sure you go slow and you pay attention to what algebra operation is being required. If I wanted to double check and make sure I was in good shape, I could just add up those four angle measures and make sure they added to 360 because of a quadrilateral. Okay, so we skipped to the second one. Let's go back to the first one because it's a little bit more of a challenge. I'm going to make it a little bit bigger on my screen. You're welcome to blow it up on yours. Remember, you can zoom in. We're supposed to find the measure of the lettered angles. We've got lots of triangles in here. We've got some quadrilaterals. We've got a pentagon. I want us to start down here because I know that this angle is 30 degrees and this angle is 90 degrees. So what would this angle be? Now that's not a lettered angle, but that would be 60, and that's going to help us. This triangle is a 30, 60, 90. What angle does that help us with? Which of our lettered angles does that give us? G, yes. Angle G is going to be 60 degrees. Now, if I know that angle G is 60 degrees, what will angle F be? Shanique, tell me how you got F as 80 degrees.
60 plus 40 is 100, and then 180 minus 100 is 80.
Perfect. So Shanique used the fact that our triangles, all the angles in the triangle add to 180. If you know that G is 60 and F is 40, I mean, G is 60, this given angle is 40, so F has to be 80 degrees. Okay, now the next place I want you guys to look is at this big triangle here. These are the three angles I want us to be interested in. That big triangle that's kind of pointing down. I know that this angle is 40, and I know that these angles are congruent. So what measure will those angles be? They have to be 70, yeah, because the three angles in a triangle add to 180. If I've already used up 40 degrees, that means I have 140 left. So that means that A is going to be 70 degrees. So A is 70 degrees. This angle is 70 degrees. I could get angle C pretty easily. Right here. What's the measure of angle C? 120, Mary, absolutely, because we've got that straight angle right there, so that has to be 120. So I'm going to erase that, and so I don't have things messed up quite as badly. That's 120. Guys, what about this angle? Because if I know it, I can get B. What's this little angle I've marked in yellow? Shanique, 50. And we're using that angles in a triangle add to 180 again. So if that angle is 50, what is the measure of angle B? Mary, perfect, 130. So we've got 130 here. Okay, so let's do this. How about if this yellow angle is 50, that means this angle is 50 because they're vertical, right? And we're told that this angle is 50. So what would be the measure of, it's going to be 80. Thank you, Sai. You knew where I was going. This one is 80. So what's H? 100. H is 100. Okay. So we're making good progress here. What angles do we still have to get? We've got A, B, C. We need D and E, right? We can do D right now. Look at the big triangle that D is part of. We've got this angle, and D making up a triangle. So what's the measure of D? And that, I didn't mean to cover up that measure. D has to be 20. Everybody good with that? And then E might be a little bit more of a challenge. Let's see if we can figure out E. Okay, I know that D is 20. I know that this angle is 80. Let's see. I don't know who raised their hand. Help me out. Go ahead.
Okay. I just got an idea for E. Since we
Okay.
have the upper angle that's 50, and we have
Okay.
a 90-degree angle,
Oh, perfect. I
we
see
can add
it.
those together and subtract 180 minus 80, right?
Yep.
That's
No, you're
going to
good.
be right.
So I just circled the 3 angles of the triangle you're looking at, right?
Yes, that's
So
going to
you've
be
got
100.
90 here and 50 there, and then this angle is what's left over. We've already got 20. If 90 and 50 is 140, right?
So we
So
have
that means this angle, yeah, and that means
total
that
angle.
E,
So E should be
perfect.
20 as well.
E is 20 as well. Everybody follow that reasoning? So for this problem, we're focusing a little less on special angle pairs and more on finding triangles and how we know that the angles in a triangle add up to 180. We're still using the concept of special angle pairs, but it's just a little bit less intense with that concept. All right, guys. I'm going to call that done. We've just done an hour today, but we got through a lot with the special angle pairs. You guys did great. I posted our attendance link. I'm so proud of myself for coming back to that. Let me post it again. I will copy and paste it again. And the question I want you to answer for your attendance today, tell me something you learned about doing simple proofs. That's what I want you to tell me for the attendance question. Tell me something you learned about doing simple proofs. What do you need to watch out for? What's going to be the tricky thing for you when you're doing simple proofs? Okay, that's your attendance response for today. I am checking email every day. I'm planning on driving home tomorrow. So I'll check email tonight. I'll try to check email in the morning before I head out. And then I will see you on Thursday. I'll be back home on Thursday, and I should be ready to go to wrap up all the rest of the stuff for the week that we didn't get done today and that we still need to do for 2-6. Does anyone have any questions for me before we go? I know I'm behind on attendance and on grading, but I promise you that I will get that caught up by next week. I appreciate your grace and your patience with me. It was unexpected. So you guys have a good week, and I will see you Thursday. Okay? Thank you all. Thank you so much.